Newton's third law of motion. Newton's third law of motion states that when two objects interact, they exert equal and opposite forces on each other. In other words, for every action, there's an equal and opposite reaction. However, it's important to note that the two forces must act on two different objects and must be the same type of force. Here's a checklist so you know how to recognise if Newton's third law of motion is happening. Check 1. There must be two forces acting on two different objects. Check 2. The two forces must be equal in size and opposite in direction. Check 3. The two forces must be the same type of force. For example, both contact forces. Here's an example so you understand better. Suppose a person is standing on the ground.
Woo! Superhero landing! Yeah, that's really hard on your knees.
And their weight of 700 newtons is pushing downward. To balance this action force, the ground must push upwards on the person with a reaction force of 700 newtons. Let's use the checklist to see if this is Newton's third law. Check 1. Are there two forces acting on two different objects? Yes. There's an action force acting on the ground and there's a reaction force acting on the person. Check 2. Are the two forces equal in size but opposite in direction? Yes. Check 3. Are the two forces the same type of force? Yes, they're both gravitational forces. So we can confirm that this is Newton's third law. Here's some more examples of Newton's third law to help this sink in. In this example, two objects, ball 1 and ball 2, both have a force exerted on them when they are pressed together. The forces are equal in size but opposite in direction. Both forces are contact forces, so this is Newton's third law. In this next example, the two objects are a person's face and the ground. The face exerts a force on the ground and the ground exerts an equal but opposite force on the face. Both forces are contact forces, so this is an example of Newton's third law. In this next example, two objects, a car and a rope, both have a force exerted on them. The rope exerts a force on the car and the car exerts an equal but opposite force on the rope. Both forces are tension forces, so this is an example of Newton's third law. When a person kicks a footy, if the person exerts a force on the ball will exert an equal but opposite force on the person's foot. Both forces are contact forces, so this is an example of Newton's third law. When a person hits a tennis ball with a racket, if the person exerts an action force on the ball will exert an equal reaction force on the racket, but in the opposite direction. Both forces are contact forces, so this is an example of Newton's third law. When a car drives down the road, the tyre pushes the road backwards, and in reaction, the road pushes the tyre forward. There's two objects with forces acting on them, the car and the road. The two forces are equal in size but opposite in direction, and they are both frictional forces, so this is an example of Newton's third law. When a satellite orbits the Earth's gravitational force pulls on the satellite, and the satellite's gravitational force pulls on the Earth. There's two objects with forces acting on them, the satellite and the Earth. The two forces are equal in size but opposite in direction, and they're both gravitational forces, so this is an example of Newton's third law. When a boxer punches a bag, the boxer exerts an action force on the bag, and the bag exerts a reaction force equal in size but opposite in direction onto the boxer. They're both contact forces, so this is an example of Newton's third law. He shouldn't hit the bag with too much force, or the bag's reaction force might be big enough to break his fist. Try this question to see if you understand. A submarine propeller exerts a force of 3000 newtons backwards onto the water. and the submarine starts moving forward. Explain why this happens. Answer. Using Newton's third law, we know that if the propeller exerts a backward force of 3000 newtons on the water, then the water will exert an equal sized force in the opposite direction on the submarine, which makes the submarine move forward. Try this question. An astronaut is fixing his spaceship from outside using a massive spanner, when suddenly the line tethering him to the spacecraft snaps and he starts floating away into space. He doesn't have a jetpack. How is he going to save his own life and get back to the spaceship? Answer. The astronaut should throw the massive spanner as hard as he can away from the spaceship. As he exerts an action force on the spanner away from the spaceship, the spanner will exert a reaction force that is equal in size but opposite in direction on him. That will push him toward the spaceship. But Newton's third law can be tricky, so I hope that's helped you to understand a little bit better. Subscribe to the channel. Thank you very much. Work hard, be nice, and bye for now.